Hello guys, so today we will discuss about the moment of force part 3 ICSE class 10. So as you understand from this heading only, we are going to discuss a topic called torque today. So in the topic called torque, it is also called moment of force. So basically our whole chapter will lie on this concept that we are going to learn today. So let us go one by one. First of all, you have to learn what is a rigid body, that we have already gone through in our video number 1. So for a rigid body, we have to learn some terms that we are going to discuss right now. So let us first go through this one. Point of action of force. Point of action of force basically means the point where the force is acting on a rigid body. So if you want to write the definition, please write it this way. The point of action of force is the point at which the force is acting on a rigid body. Okay, so if I have considered this as the rigid body, you see I have applied a force like this. This is pivoted over here. At this point it is pivoted, and I have applied a force vertically upwards in this direction. So the point of action of force is this point. I can name it as P. So point of action of force is at this point. Okay, and there is another term which is called line of action of force. Line of action of force basically means is the direction of force with respect to that body. Line of action of force is an imaginary line which acts in the direction which is in the direction of the force. It is an imaginary line on which the force is acting, or in which direction the force is going through. So if I see this force, basically this force is going through this line. So this is the line of action of force. So line of action is an imaginary line. It is an imaginary line along which the force is acting. Okay, so line of action of force is an imaginary line along which the force is acting. That is it, nothing much. So I hope you can understand this one. And so these terms are very important because these terms will define how you understand the moment of force later on, because I am going to use both these terms time and time again in this chapter. So the next one is principle of transmissibility of force. You have to understand one thing. If a force is applied to a rigid body, it will pass through the line of action of force and cause the body to move, that we know, but it will not change any material nature of the body. So basically, principle of transmissibility of force says that the force acting on any rigid body will cause the motion through the rigid body without causing any material change in the rigid body. Material change हो गया, इसका मतलब केमिकल चेंज हो जाएगा, वो सब तो होने वाला नहीं है, फिजिक्स पढ़ रहे हैं हम लोग. So basically it will cause the motion, but there won't be any material change inside the body. So that is basically principle of transmissibility of force. Now coming to the torque. Now as we have understood at this moment what is point of action of force and what is line of action of force, both these are understood to us. So if you see, again I am repeating these things, though it is not required. I hope you have understood it already. Point of action of force is the point on the rigid body where the force is acting. Line of action of force is an imaginary line along which the force is acting. That is it. So these two will be very much used in our later part. So now first of all, we have already seen this example in our last video. This is a door with a hinge. So a typical example of moment of force applications. So if you see over here, if I give a force perpendicular to this direction, means like this, if I show it like this, so this door will basically close, having a rotational motion which I explained in my last video. This will be what kind of rotational motion? This will be clockwise rotational motion, because it is going around just like a clock. If the force was given like this, then the door would have been opened in this direction. It would have been anti-clockwise motion. So now at this moment the door is going to close. in a clockwise motion. So if I ask you what is the point of application of force in my first case, then this will be the point of application of force P. Okay, and if I ask you what is the pivoted point, this is the pivoted point, or pivoted point is also called axis of rotation. So this is the point of application of force or point of action of force, and this is the axis of rotation or pivot. Now number two thing is we have to understand which is the line of action of force at this moment. This is the line of action of force. If you wonder, this is the imaginary line. If I draw over here, then this will be the line of action of force. Okay, now I can define another thing which will be very important while understanding the moment of force at this moment. So I'll draw a simpler diagram. This diagram will do. Here the line of action of force is this one, and the pivoted point is this one. You look at this distance. This is basically, what is this? This is basically perpendicular distance of the line of action of force from the axis of rotation or pivot. Okay, so this distance is very important. Why this distance is important, I would like to explain over here again. If you push this door from this point, say A, which is very close to the axis of rotation, okay, if I push it from here, you can go to any door and try pushing it from closer to the hinge position. It will be very difficult for you to push it open or push it close. Okay, but on the other hand, if you push it at the edge, it is easier for you. See, if I push it at the edge, if I name it as B and if I name it as A, okay, so if I name it as B, if I push at point B, then the perpendicular distance from the pivot is this much. I take it dB, and if you take this point A, this is very small distance, and this I take dA. So it is clear that dB is more than dA. Now what is this d? This is perpendicular. This is perpendicular distance. D is perpendicular distance of line of action of force from axis of rotation. So one thing is for sure, if this distance is more, then it is easier for us to push, and if this distance is less, it becomes much harder for us to push. So we will go one by one now. Now we have understood there is another term which we had not named, that is the perpendicular distance from the line of action of force from the pivoted point or axis of rotation. Okay, so coming back to the torque, so this gives you an idea of torque basically. What is a torque? This whole thing we are discussing, we have not named it. So we are now going to give it a name. So all these things, this rotational motion, whatever is happening at this moment is due to a phenomenon or a force or a moment of force or what is called torque. Okay, the reason behind all this motion is torque, because now we are going to define what is torque. Torque is basically product of magnitude of force and perpendicular distance of line of action of force from axis of rotation. So mathematically, if I want to write what is torque over here, then it will be force into D. So force is the amount of force that we are pushing. And what is D? D is the perpendicular distance of the line of action of force from the axis of rotation. So you can say that mathematically the definition of torque is product of magnitude of force and perpendicular distance of the line of action of force from axis of rotation. So if I term this at F into D, I can clearly know that this is also called moment of force, as already explained. So this is also called moment of force. This whole phenomenon, what is happening right now, that if I reduce the D, the amount of force that I have to give is much more, is only due to the moment of force. Okay, so if you see this one, the unit for this will be Newton into SI unit of distance is meter, so it will be Newton meter. And what kind of quantity will be torque? As we have seen right now that this has some direction clockwise and anti-clockwise. This torque or moment of force has some direction clockwise or anti-clockwise. So obviously it will be a vector quantity. Okay. So the unit for this torque is Newton meter, and the torque is having a direction, that is why it is a vector quantity. So these two things must be very clear, and this short questions always come from all these things. What is the unit of torque, SI unit, what kind of quantity is this? So you must be very much conversant with it. Okay, so the basic thing that we wanted to understand from this lesson was torque. The phenomenon torque, this is associated with rotational motion. Okay, so for pushing this door to the closed position, I need a specific moment of force. Okay, I need a specific moment of force. Now I can I can apply this moment of force in two ways. Number one is by producing lot of force from my body and pushing it from a position which is close to the pivot or the axis of rotation. So suppose I require 10 Newton meter of torque to push this door. Okay, so okay, so 10 Newton meter is my torque requirement. So I can correctly write it F into D. So if you see, this thing I can do it in two ways. One is I keep the distance 2 meter, that is close to the door hinge, very close to the door hinge. So how much force do I need to produce to get 10 Newton meter? 5 Newton, because 5 Newton into 2 meter will give me 10 Newton meter. Next is, if I keep the D, that is the distance from the hinge or the pivoted point or the axis of rotation, large, say 10 meters, then how much force do I have to generate? Only 1 Newton. So my dear friend, which is easier for you, to generate 1 Newton or 5 Newton? Obviously it is easier for us to generate 5 Newton. So sorry, 1 Newton. So it is easier for us to generate 1 Newton. So I'll generate 1 Newton and I'll keep the distance from the pivot or the axis of rotation much longer, so that my energy from my body goes in lesser content. Okay, otherwise energy from my body will go in a higher content. 5 Newton will go from my hand only. So there is no point in doing that. That is why whenever we open or close the door handles are always very far away from the pivot or the hinge, or in our words it is axis of rotation. Okay, so if I ask you right now, what are the two factors on which the moment of force or torque will depend? So there are two factors on which the moment of force or the torque will depend, which is very much clear from this. One is the magnitude of the force. Please note it down. Two factors on which the moment of force or the torque will depend. Number one is the magnitude of the force. Number two is the perpendicular distance of the line of action of force from the axis of rotation. So these are the two things on which the moment of force will depend. If any of these two things increases, the moment of force will increase. Okay. So this was a very important thing that we discussed today, and after this we will discuss clockwise moments, anti-clockwise moments and principle of moments. So that will be discussed in the next class. Thank you.